Okay, we are taking a look at levers. Let's see what we've got here. So just reviewing IMA, the effort distance divided by the resistance distance. Greater than 1, it's easier. Less than 1, it is harder. And that is important because we're going to have some of both when we're talking about levers. For two of our levers, first and second class levers, the IMA will be greater than 1. It will be easier to do the work. But for third class levers, the IMA will be less than 1. So why do we use that? Well, sports equipment like a hockey stick, you don't want to lift the puck. You want to have the end of the hockey stick going as fast as possible so that the puck goes fast. Or a fishing net. Your two hands are the fulcrum and the effort, and then you have the fish down there in the net. It doesn't make it easier to lift the fish, but you don't have to climb in the lake in order to go get it. So that's nice. So let's take a look at a couple of examples of levers, and we'll just kind of double check. If it's first or second, is it greater than 1? If it's a third class lever, is it less than 1? If so, then we're probably on the right track. Okay. Over here, we've got a fulcrum in the middle. Fulcrum is the triangle there. The little arrow is our effort, and then we have a box for the load. So when the fulcrum is in the middle, just like a seesaw on the playground, that tells you right away, first class lever. Okay. Our effort side is over here. So I'll just label that. And then our resistance is there. So now we've got our IMA formula. We just have to put the numbers in the right place. 5 meters divided by 2 meters is an IMA of 2.5. Okay. Looks good because it's a first class lever. So we would expect greater than 1. Okay. Seesaw, fulcrum in the middle, same thing. You can do that yourself. Over here, we've got the fulcrum, load, effort. Okay, this is a wheelbarrow because you push up on the handle in order to lift the bricks or the dirt and stuff that's in the wheelbarrow part, and then the wheel itself is the fulcrum. So wheelbarrows are second class levers. And we see here that the distances actually overlap because these distances are the distance between the effort and the fulcrum and the distance between the load and the fulcrum. So they can, in fact, overlap each other as they do here. Okay, effort, resistance, put them in the right order. 22 meters divided by 4 meters. Meters cancel out. And then we are looking at an IMA of 5.5. Awesome. All right. Notice on this one, meters, centimeters. So you have to convert before you do it, and then you can go ahead and do that one. But I didn't give us an example of a third class lever in these 4. So let's go ahead and just make one. So I'm going to put the effort next to the fulcrum and then the load way out here. Okay. You can probably see this is going to be harder to lift. Okay. There's probably a weight machine in the weight room that has this type of setup. Okay. So it's not designed to make it easier. So we'll say this is 4 meters. This is the effort. And then the distance to the load, 10 meters. So now we have to put them in the right spot. Most of the time with levers, like over here, the big number is on top. Here, it's the little number. So just get used to looking, what's the distance for the effort that goes on top, and the resistance distance goes on the bottom. Meters cancel out. 0.4. Hallelujah, because third class lever, we expect our answer to be less than 1. It's not easier, but we're going to do something else. That's the reason why we're using that lever. All right, hope it makes sense, but let me know if you have any questions and give it a try. Good luck with your levers.